Hello and welcome to this another video of business statistics. So today we will start with the new topic, graphical representation of data. So basically graphical representation of data means it convert raw data into meaningful visual form. So, with the help of graphical presentation, we can convert a complex data into a meaningful data. Okay. Graphical representation is the visual representation of information by using graphs and charts. So basically, it transforms numbers, numerical data, or the categorical data into easy to understand visual format, which makes complex information more accessible and insightful. So when we collect data through primary source or the secondary source, we convert that data into numerical or the categorical data. After that, we convert that numerical or categorical data into visual format, into graphs, into charts. We convert graphs like bar graph, line graph, pie charts, histograms, scattered plots, etc. So basically, in graphical representation, we use graphs like bar graph, line graphs, pie charts, histogram, scattered plots, and other commonly used display data, graphs which used to display the data. So each type of graph has a specific purpose. So they all type of graphs and chart are very different from each other, and every graph has a specific purpose. Like bar graph are used for effectiveness or to compare quantities between different categories. After that, line graphs basically show the trends over a period of time. Suppose for last 10 years we want to see the trend of purchasing power of household, so we can check that last year data with the help of line graph. After that, pie charts depicts properties of a whole. Histogram basically illustrate frequency distribution of numerical data, and scattered plot basically reveals relationship between the variables. So scatter relationship between the variables like independent variable and dependent variable. If we want to see the difference between dependent and independent variable, then we use scattered plots. So basically, the primary advantage of graphical presentation includes the clarity, efficiency in conveying the large amount of data quickly. And it also highlights or it is highlights the trends and the pattern and the relationship which might you cannot which cannot be easily apparent by the raw data. So for decision makers, researchers, and decision makers, researchers, and analysts across various fields, like from for business, economics, social science, and science, graphs and charts provide a powerful tool for data analysis, interpretation, and communication. So this simplifies the this simplifies the process of making informed decision and communication insights effectively to stakeholders. So this is the basic meaning of graphical presentation, or we can say that this is the objective or primary purpose of preparing graphical representation of the data. Now there are some general rules for graphical presentation of the data. So there are certain guidelines for an effective and attractive graphical presentation of the data. So these guidelines, in the guidelines we use suitable title, unit of measures, suitable scale, index, data source, keep it simple and neat. Diagram should be neat. So let us discuss these guidelines in briefly. First one is suitable title. So when we start with graphical presentation, we should ensure that uh, there should be a suitable title to the graph, which clearly indicates the subject for which we are presenting that graph. So select a graph type that best represent the data you want to visualize or you want to show. So common type includes bar graph, line graph, pie chart, scattered plot, and histogram. I have earlier also told these types of graphs. After that, unit of measures. So while preparing a graph or while preparing your raw data into graphical representation, the clear state, you should clearly state the unit of measures below the titles. If it is in kilogram, or if it is in centimeter, or it is in meters, so it should be clearly measured below the title. After that, suitable scale. So when you choose a suitable scale for graphical representation, means you can represent the entire data into or in a accurate manner. So you should maintain consistent scaling on both x-axis and the y-axis. So scaling on both axes to is accurately represent the relationship between the data points. So inappropriate scaling can distort the visual representation of the data. So scaling should be proper on both x-axis and the y-axis of a graph. After that, index. So basically index include a brief explanation of different color and shades, line, design that are used for making a graph. So basically color, shades, line and designs make a graphical presentation more attractive and more effective. So it can be easily understandable. Also, it includes a scale of interpretation for better understanding. Next point is data source. So, whenever possible, include the source of information at the bottom of the graph. So, when we are not making a graph by ourselves, then if we are copying that graph from some other source, or we are taking that graph from the other source which has been already published, so we should have to mention that source at the bottom of the graph. Okay, after that, keep it simple. So basically you should construct a graph which even a layman can understand without any exposure in the area of statistics or mathematics. If any person is like that, so it can be understandable for that also. So you should ensure all the elements of graph are clearly labeled. It should be it should include x-axis also. It should be the data points, the categories and the unit of measure they all should be clearly mentioned, and it make very simple for a layman to understand that graph. So clarity is labeling prevent from the confusion and the misinterpretation also. Next point is neat. So basically a graph is a visual aid for the presentation of the data and information. So therefore, you must keep it neat and attractive. So you must choose the right size, right lettering, and the appropriate lines, appropriate color, appropriate space between the graphs, between the lines, etc. So graphical visualization should be neat and clean. So it can be easily understandable for any person. So these are the guidelines which should be used while representing data graphically. So next point came is advantage of graph and disadvantages of graphs. So let's start with the advantages of graph. So basically, in simple language, we can say that graph present the data in a manner which is easier to understand. Basically, graph save times. Okay, so it allows us to present statistical data, large number of data in an attractive manner as compared to the table. So basically, users can understand the main feature, trends and the fluctuations of the data at a glance. So basically, viewer does not require prior knowledge of mathematics or the statistics to understand a graph. So graphs are easily understandable when they are visualized. Okay, so it basically allow the viewer to compare data relating to two different time period or two different region with the help of the diagram. So we can use graphs to locate the mean, median, mode value of the data also. It also helps in forecasting of the data also. Now let us discuss the advantages of graph in brief also. So first point is representing complex data. So basically, graphs are very effective tools for representing a complex data. So especially when the relationship between the data points are not straightforward, then graphical representation helps in understanding that. So they can help to uncover the pattern, uncover the trend, and uncover the insight that may be difficult to see by using other methods also. So basically, graphical representation make complex data, numerical data into representation form, which is very easy to understand. Next point is efficient data process. So, graphs basically can be processed efficiently by using graph algorithm also, which are specially designed to work with graph data structures. So basically, this make it possible to perform complex operations and large data set quickly and effectively. So basically, representation effectively process the data also. Next one is network analysis. So network analysis means when graph are commonly used in network analysis to study the relationship among the individual or among the organization, as well as to identify important nodes and edge in a network. This is useful in a variety of field, including social science, business, market, planning, education, in various fields also. Okay, so network analysis is very easier with the help of the graphical representation. After that, path finding. So basically, graphs reduce or shorter the path distance between the 2 points. Okay, so where there is a common problem in computer science, logistic, and transportation planning, it shorter the path distance or path between 2 points. So this is how it helps in path finding also. Next point is visualization. So graphs are highly visualized as they are very attractive. There are so many colors in that, there are lines, and they are properly made, they are very neat, and they are easy to understand. So they have high visuals. So basically, high visuals make easy to communicate complex data and relationship between the variables in a clear and very concise way. So this process basically makes them very useful for presenting their report, for also helps in data analysis for researcher also. So when any organization or any researcher is doing research on any topic or uh, find out any results, so they basically use this graphical presentation to uh, communicate their complex data to the audience. Last point is machine learning. So basically, graph can be used in machine learning also, where the model complex relationship between the variables, independent variable and independent variables are there. So such type of recommendations system or the fraud detection can be reduced. So these are the points of advantages of graph. Now let us discuss in detail the disadvantages of graph. There are some advantage of graph making, so there are some disadvantages also for making a graph. First one is limited representation. This means that graphs can only represent relationship between the objects and not their properties or their attributes. If we want to find out the relationship between the properties or the attributes, we have to apply some other statistics test like regression or correlation, these type of tests. With the help of graphical representation, we cannot find the relationship between the properties or the attributes. So basically, this means that in order to this means that in order to fully understand the data, it may be necessary to supplement the graph with additional information also. Next point is difficulty in interpretation. So as graphs can be difficult to interpret also, especially if there are large or complex data, they are difficult to interpret. So this can be make it challenging to extract meaningful insight from the data. So we can say that it may require advanced analyst techniques or domain expertise to interpret that graphical representation. Next point is scalability issues. So, in graphical representation, as the number of nodes and edges in a graph increases, so the processing time and the memory required to analyze it also increases. So basically, this can make it difficult to work with large or complex graphs also. So basically, there is always a issue of scaling in graphical representation. Next point is data quality issue. As graphs are only as good as the data they are based on, and they are based on and if the data is incomplete and inconsistent, or we can say that the data is inaccurate, the graph may be show a wrong relationship between the object. So there is always a quality issue while preparing a graphical representation. Next point is lack of standardization. So as there are many different types of graphs and each graph has its own strength and own weakness. So this can make it difficult to compare graph from different sources. So to choose the best type of graph for an analysis is very difficult. So there is always a lack of standardization while choosing a best graph for your data presentation. Last point is privacy concern. As graph reveal several and the large data into a graphical form, so there is always a sensitive information about any individual, about any organization, about any researcher, which can raise a privacy concern, especially in the social network analysis and marketing, or you can say in marketing analysis. So there is always a privacy concern while representing your data through graphical form. So these are the basically disadvantages of graphical representation. Now, let's next topic is diagrammatic representation of the data. So, what is diagrammatic representation of the data is when we use the diagrams to illustrate the statistic data is very is called diagrammatic representation of the data. So, use of diagrams in statistics is very important and is very essential. So the greatest way for representing any numerical data is obtained in statistics is through diagrammatic representations. So basically, it effectively convert the exceedingly complex ideas which contains in numbers into a more concerned and reliable, understandable form. So although diagrams are less certain, they are far more effective in displaying data than a table. So there are numerous types of diagrammatic use which are done in statistics also. So similarly, the diagrammatic representation of the data gives a lot of information regarding the numerical data. So this can be understand with the help of the diagrams, which we will discuss later, the diagrammatic representation in details. So basically, what diagrammatic representation actually means. So it means that it is a representation of any numerical data by using diagrams is known as diagrammatic representation. So diagrammatic representation basically gives a simple and easy understanding of any numerical data which is collected as compared with the tabular form of the data or textual form of the data. So, as there is a famous quote which is given on the this diagrammatic data is that a picture speaks more than a word. So similarly, when we represent a statistical data, the essential tool in the diagrams are used. So basically, diagrammatic data represents or translate the high complex data including the given numbers into a concern or a pretty effective or a simple understandable manner. So basically, diagrammatic representation uses geometrical figures or a diagram which improve the presentation of the data. So diagrammatic representation are in visual forms through which we can easily understand them. Uh, we can convert a large raw data of statistics into a figure or into a diagram so that it can be easily understandable by any uh, any person. So, if we talk about the basis of diagrammatic representation, then it means that diagrammatic representation of data basically gives a lot of information regarding numerical data. So, basically, it is more effective and very easy way of representing any numerical data. in a statistic basically. So diagrammatic representation are basically visual assistance which is provided to any reader. So diagrammatic representation use the geometrical figure or diagram to improve the data presentation. These diagrams can be such as cartography, pictography, pie chart, bar diagram, etc. So these can be used while presenting statistical data. Basically, bar graph are represented by rectangular bar in which the height of the bar given the value of frequency of the variables. In pie chart, there is a circle which is divided into parts. It is basically in percentage form. A line representation of data, basically we use line to convert the various portion of or parts to plot the data on the graph. So these types of graph and pie charts or line we will discuss in detail also. So these are the types which are used to represent uh, large statistical data into a graphical form. So, the types of diagram which we will discuss in detail are bar diagram, histogram, pie chart, line diagram, frequency polygon. So these are the types of chart which are commonly used while presenting large raw data of statistics. So these types of charts or diagrams basically are commonly used while presenting data in statistics by the researcher to present their data, and they are commonly used in everywhere in every type of research. Now let's start with the bar graph, or we can say let's bar diagram. So basically, uh, bar diagram are commonly used while presenting large data into a statistical form. So what is the meaning of bar diagram? Let us understand first that. So, as bar diagram is the simplest technique which is used to comprise the large set of the data. So, a bar graph is a graphical presentation of the data in the form of a rectangular bar, as you can see in this picture also on your screen, or they are in basically they are in the form of rectangular bars or the column of each width. So it is the simplest one, and it is the easiest way to understand among the graphs by a group of people. So basically, why construction of bar diagram is done. So if we talk about the construction of bar diagrams, so there are two perpendicular lines which are intersect each other at a point zero, which are x-axis and the y-axis. So the vertical line is the y-axis and the horizontal line is the x-axis, as you can see on your screen in the this graph also. So you have to choose a suitable scale to determine the height of each bar. Okay, so as in starting, we also discussed the guidelines for preparing a graph. So you have to choose a suitable scale for determining the height of each bar. So on the horizontal line, you can draw a bar with the equal distance with corresponding heights according to your data. So the space between the bars should be equal, as you can see in the diagram also. So this is how you can prepare, or one can prepare a bar graph. After that, if we talk about the properties of bar diagram, so all bars have a common base. when we draw a bar diagram. So all bars which we are drawing or which we are plotting on a bar diagram, so they should have a common base. Each bar or each column in a bar graph is of equal width. The width of each bar should be equal. So the purpose of this equal width is that it should be clean or it should be neat, so that anyone can understand it easily. After that, the height of the bar should be corresponding to the value of the data. So the distance between each bar is the same, as you can see in this picture also. So there is a equal distance between each bar. There is a common base also. So and the column in this bar graph is of equal width. So these are the properties of making a bar diagram. After that, there are two types of bar diagram basically. One is vertical bar diagram and one is horizontal bar diagram. It depends totally on your choice that what type of bar graph you are going to draw for showing your raw data or your large statistical data. So basically, horizontal bar diagram is used for qualitative data, and the vertical bar diagram is used for quantitative data, or you can say for time series data. When we have to show data of last 10 years, that is called time series data. Then we will show that data in a vertical bar. So these are the two types of bar diagram, vertical and the horizontal bar diagram. One is used for qualitative data and other one is used for quantitative data. There is one point, let's discuss the advantage and disadvantages of bar diagram also. Let's understand the advantages and disadvantages of a bar graph. Um, if we talk about the advantages of bar graph, then a bar graph summarize the large data set into a simplest visual form. Advantages and disadvantages of a bar diagram or a bar graph are that a bar graph summarize a large data set into a simple visual form. Basically, it displays each category of data in the frequency distribution. Uh, we- uh, it, it basically clarifies the trend of data better than the table, as you can show a time series data in a bar graph, which show a pattern from various years also. So basically, it helps in estimating the key value at a glance. So basically, preparing a bar graph is very easy, or you can say it show a large data set in a simple visual form. It can convert it can show various category of the data also. If we talk about the disadvantages of bar graph, then sometimes what happen is that bar graph fails to reveal the pattern and the cause effect of the large statistical data. So it can be easily manipulated, or it can sometimes give fake information with the help of bar diagram. So if there are some advantages of a bar graph, preparing a bar graph, then there are some disadvantages also of preparing a bar graph. Now let's come to the next part, which is histogram. Um, Histogram is another way for diagrammatical representation of the data, as we have discussed earlier. The bar diagram. This is also similarly, but little different from bar diagram. So, if we are working with a continuous series data set or a group data set, then we can use a histogram for representing the data. When we collect data from primary source or the secondary source, then we convert that data into a continuous data or a group data set. Then after that we represent that data graphically or diagrammatically. So when we have continuous type of data set, then we can use histogram for the representation of that data. So basically, a histogram is very similar to bar graph, which is expect for the fact that there is no age between, or there is no gap between the rectangular bar, as we can, as you can see on your screen in this diagram or in this histogram, which is mentioned, that the rectangular bars show the area proportion to the frequency of a variable, and the width of the bars represent the classes or the class interval. Basically, frequency means the number of times a variable is occurring or is presenting the data. So it is a area graph basically, which shows the height of a rectangular and proportion to the corresponding frequency of a similar class. As bar graph, there is all in histogram also there is a x-axis and the y-axis, in which we show our statistical data. Now, if we talk about the construction of histogram, then how we can construct a histogram? So basically, we have to draw two perpendicular lines which are intersecting each other at a point 0. So the vertical line is y-axis and the horizontal line is the x-axis, as we have also discussed in bar diagram. So for we have to choose a suitable case for both the x-axis and the y-axis, which can determine the height and the width of the bar. So basically, on the horizontal line, we draw the bars with corresponding heights as the available data. The data set which we have available with us, we draw the bars with corresponding heights. So there should be no gap between two corresponding bars, with showing the continuity of the data. This is how we can construct a histogram. So there should be no gap between the consecutive bars. The frequency, the group frequency are not continuous. The first thing to do is to make the continuous data. So after that, we can say that it is done by adding the average of the difference between the lower limit and the class interval and the upper limit of the preceding class width to the upper limit of all the classes. The same quality is abstracted from the lower limit of the class. So this is how we make a histogram. So there are some properties also for making a histogram. So what are these properties are that uh, some properties we have already discussed in the construction of histogram. Let's once again also discuss the property of histogram. So as each bar or each column in a bar graph, or we can say in a histogram, should be equal width and corresponding to each class interval. So basically, height of a bar corresponds to the frequency of the data. Uh, as we can see in this diagram or in this picture, we have shown how the type of histogram is. So this is how we can make a histogram with a graphical representation. Now let's come to the line graph. So next type of graphical representation is line graph. So what is line graph is basically a line graph is a type of chart, or we can say it's a type of graph which show information when a series of data is joined by a line, as we can see in this picture also, when a data is joined by a line. So in a we can say that in a simple line graph we plot each pair of value x. We can say value like x and y. Here in this line graph, x-axis denotes the various time points and the y-axis denotes the observation based on the time. So how basically this line graph is drawn. So as we talk about the properties of line graph, it consists of vertical and horizontal scale. These scale may or not be uniform. So the data point in graphs are basically it consists vertical and horizontal scale. These scale may be or may not be uniform. Next property is that the data point is correspondence to the change over a period of time. The line which is joining these data sets from one data point to another show the trend of the change. So as in this diagram, in this given below graph, it shows the number of buses which are passing through a particular street over a period of time. So this is how one can make a line graph with the help of large number of statistical data set. Now next come with the pie chart. Come to next point, pie chart, which is another form of graphical representation of data. Basically, a pie chart is a circular graph which is divided into numeric numbers of portion. As you can see in this diagram, pie chart is a circular form and it is divided in various portions which represent a percentage of a particular part or particular topic for which we are creating a pie chart. So each slice in a pie chart represent a categories which share a contribution to a whole. So as pie chart is known as a circle chart, which is divided the circular statistics into graphs, or we can say into sectors or in sections which can illustrate the numerical problems. So each sector basically, or you can say each section basically denotes a proportion part of the whole data. So basically, to find out the composition of something, pie charts will work the best at that time. So in most cases, pie chart can replace other graphs like bar graph, histogram, plots, etc. So these pie chart can easily represent a portion of data in a simpler and easiest form, which can be understandable by any person. So for this, total value of pi always 100%, and these parts, as you can see in this diagram, this whole circle is 100%, and these parts are divided in percentage, which will in total they will be 100%. So when we apply a formula, then a pie chart is an important type of data representation. It always contain different segments and sectors, basically in which each segment and sector of a pie chart form a specific portion of the total percentage. So the sum of all the data is equal to 360 degree. The total value of pi will always 100%, as I've also told earlier. So when we have to work out with the percentage for a pie chart, we have to follow some steps. For working out of percentage for a pie chart, we have to follow few steps, like we have to categorize the data, we have to calculate the total of that data, we have to divide those categories, we have to convert our data into percentage, finally we have to calculate a degree. So it is very much important for calculating whole data set into percentage, and after that we have to calculate a degree. For if we talk about the formula of pie chart, then the formula of pie chart will be given data which is divided by total value of data, and we will multiply this with 360 degree. So that will be the formula for pie chart. Uh, there is one important point is that it is not very mandatory to convert the given data into percentage until it is specified. Okay, it is not important. It is not mandatory to convert the data into percentage. Okay, we can directly calculate the degree for given data value, and we can draw a pie chart accordingly. Okay, so there are some we can say there are some very important points for a pie chart. As a pie chart should be in circular representation, there should be categories, there is a visual comparison, there should be limited categories, it is very simple to understand. uh, for a pie chart, as you can see in this diagram, this pie chart is in circular representation. So what it basically means is that the entire pie represent 100% of the total or of the total data, which with which we can represent a portion or we can represent a part. So after that we have to categorize or we have to give segment to the pie so that it can be easily understandable. Okay, so these segments show a specific percentage on the basis of whole. So pie chart basically visually compared proportion, okay, which make it easy to understand and which make a large data into a smaller one and make a very relatable to others. Okay, so pie charts make a complex data into simpler visual breakdowns. Breakdowns like into percentage, it convert the whole data into percentage, which is easy to understand. Okay, so basically, pie charts are widely used in presenting, in the presentation and in the reports and the publication of categorical data effectively. So basically, they are effective for showing part of whole data, and they can highlight relative portion or distribution within a data set. So this is pie chart. Now let's come to frequency polygon. What is frequency polygon? So basically frequency polygon is also a part of graphical representation of data. So when frequency histogram has the similarity to a column graph with the presence of space between column, that is frequency polygon. So frequency polygon basically happens to be a special line graph which is used to take place in statistics. Anyone can draw these graph either separately or you can make it combinedly. One can make use of the information that is available in the frequency distribution table for drawing of these graph. In simple terms, we can say that frequency polygon is a type of graph which show that the distribution of data is very easy. It use points, connects by straight line to, as you can see in this diagram, it use points which can connect by straight lines to represent how often different value or different categories can occur. So basically, it's like graph, but specially it is used to display frequencies, or you can say it is used for counts of data, or interval, or category, which help in visualizing pattern and trends in data distribution. As there are some steps to draw a frequency polygon. On screen, you can see one example of frequency polygon. Here, this is a question, and this is the answer of this question. On the basis of this answer, we have created a frequency polygon. I think it is clearly visible to all. So let's talk about first. Let's talk about the steps for drawing a frequency distribution. So you have to mark the class interval for each class on the horizontal x-axis, and then we will plot the frequency on the vertical axis. So there are two axes, x-axis and y-axis. One is horizontal, one is vertical. We have to calculate the class marks for each class interval. How can we calculate the class marks? So class marks will always equal to upper limit plus lower limit divided by 2. This is the formula for calculating class marks. So marks of all the classes make marks on the horizontal x-axis. It is also known as the mid value of every class. Okay, so after that, corresponding to each class mark, we have to plot the frequency as given to you. So the height always depicts the frequency. So we have to make sure that the frequency is plotted against the marks and the upper or the lower limit of the class. So basically, this result shows the curve which is called frequency polygon. As we can see in this diagram, this curve show a frequency polygon. As let's understand this question, there is a test score given and the frequency given in this question. So for this, we have to calculate the cumulative frequency. So as we have already calculated the cumulative frequency in this for answer of this question. So the total of this frequency is 100. So we are adding this frequency. First is 5. After that 5 plus 10, 50. 15 plus 30, 45, 45 plus 40, 85, and 85 plus 15, 100. So this is our cumulative frequency. So for this, we have plotted this frequency polygon. This is how we can show our data with the help of frequency polygon. So This is frequency polygon. So these are some commonly used types of this diagrammatic representation. We have discussed all these points in detail: bar diagram, histogram, line diagram, pie chart, frequency polygon. Okay. So after understanding this, let's discuss the difference between the graph and the diagram, or you can say the difference between graph and the let's first understand what is the difference between graph and the diagram before going towards the difference between graphs and charts. Let's first understand what is the difference between graphs and diagram. So basically all graphs uh, are a diagram, but all diagram are not graphs. Okay, so this means that diagram is only a subset of a graph. After that, graphs are are representation to a scale, whereas a diagram need not to be in scale. Okay. Next is if we talk about graph. Graph is a representation of information using lines on two or three x-axis like x, y, and z. Whereas diagram is a simple pictorial representation of what we want to look or how it will work. Okay, so value of mean and median can be calculated through graph, which is not possible through diagram. So graph are drawn on a graph paper, whereas diagram do not need to be on graph paper. Okay, so this is the basic difference between graph and diagram. Let's understand the difference between graph and the chart. So in this chart, there are three headings given: basis, graph, and chart. So first is main goal. So basically, the main goal of graph is to show different things which are related to or which are related to each other. Okay, and chart basically make us understand and make us compare data. So basically, with the help of chart, data is easily understandable and it is easily comparable among the variables. Next point is use case. So, in graph, it is often found in science and math to study data. So, basically, graph are generally used in mathematics and in science, whereas charts are used by businessmen by and for sharing news or for sharing information quickly. Data representation basically graph focus on the connection between the numbers. Okay, and whereas chart highlights the part of the data, like how much there is of something, like that. Variations uh, graph includes type like line graph, scattered plot for variations, whereas chart includes bar diagram, bar charts, pie charts for variation. Simplicity. Graphs are very complex with lots of data or the large data set, whereas charts is very simple to look with the large data set, or they are easy to make with the large data set. User interaction. So basically, graph need more user interaction or more understanding, whereas charts are made to be quickly understandable without much study. Level of detail. So basically, graph provide in-depth view into a data behavior, whereas chart offer broad summary which focus on the main facts. Now audience, so basically graph target that audience which is very familiar to their data or they're familiar with their data analysis, whereas chart aim at a broader audience for quick comparison and decision making.